It wasn't that good. Okay, let's turn to page. Oh, y'all were here yesterday, right?
Yeah.
So we went through part D. Go down to part E of the notes. For you people at home watching this, all three of you, if you didn't catch yesterday's discussion of part D on tilling, slash and burn, and fertilizers, you missed out on something delicious.
Are we gonna go through all of part E?
We're going to go through all of part E, yes. Turn to page 244. Irrigation. What is irrigation? Come, Jemiah?
What's your name?
What? Yell it louder. Moisture? I mean, it does involve water. Give me more. Jordan.
Like how you water like soil and
Yeah, how you water plants. So irrigation is watering the plants, and in most places you have to do this in order to grow crops because a lot of times they don't get enough water or consistent water. So they have to water the plants. 70% of human fresh water in the United States, or human fresh water overall, goes to what? This isn't in the U.S. This is just talking about overall.
Watering plants.
Irrigation. The most watered plant in the U.S. is grass. Dang, you're good. Got it. Turf grass, sod, your lawn. That is the #1 most irrigated plant in the United States. Grass, not talking about the other, a lot of times what people refer to grass. I'm talking about grass on your lawn. You know what I mean? Good. Drugs are bad. All right. 244. How do we get that water to different locations in order to water? Well, sometimes we have to use canals or channels, or the Romans might have used aqueducts. Yes, the Romans were famous for their aqueducts. And there's one on page 244 here. Why don't you read that for us? Kayla, go. Yeah.
Okay. Aqueducts deliver water from places where it is abundant to places where it is needed. This section of the Colorado River aqueduct, which diverts water from the Colorado River to Los Angeles, passes through the Mojave River.
I think it's pronounced Los Angeles, but I don't know. It means the Angeles. No, that's not right. I think it's City of Angels. Is that right?
Just get a grip.
Has anybody in here been to Los Angeles? You probably would have died from smog. Okay, so it is smoggy. But a beautiful city this time of the year for anybody out there listening on the internet to this in Los Angeles, which I doubt will never happen. All right, good. So aqueducts. The Colorado River starts in Colorado, bebops through Arizona. I think maybe hits Utah a little bit, and then goes through Arizona, the Grand Canyon. Anybody been there? That river at the bottom, that's the Colorado. Goes through there, through Southern California, down to the Baja Peninsula in Mexico. Now, what's the one thing you notice about this aqueduct?
It's not a straight line.
Well, it's not straight, but is it a lot or a little water? I don't know. I mean, it's got to be like 20, 30 feet wide. That's pretty big. I would think compared to the Colorado, and you're pulling that much out all the time. It doesn't take a lot of aqueducts like this to, or pumping stations to pump a lot of water out. Just imagine like the Colorado River is a giant milkshake, Luke. Everybody's got a straw in it. Looks like Los Angeles has the biggest straw of them all. And by the time the Colorado River gets to Mexico and almost goes out into the Bajas, whatever that sea is down there, then there's not much left of it. Okay? What? The what? Bering Sea, that's up in Alaska. It's wherever the Baja Peninsula is, that little piece in between it and Mexico there. Anyway, so there's not much left by the time it gets there because so many people are using that water. Now, some of this is for irrigation. Some of it is for just drinking water. I mean, LA is probably 10 million people in the greater Los Angeles area. So it requires lots and lots of water for those people who decided to move out into the desert where there's not hardly any fresh water. Good move, people. All right. What types of irrigation are there? Good question. 247. At the bottom of 247, we see the different types. let's look and talk about some characteristics of each one. Drip irrigation. Now, just by looking at drip, this is where you have like a perforated pipe, so water just drips out of it. What would the benefits of drip irrigation be?
You get continuous amount of water.
Well, for any of these, like if you're pouring water out, you're going to get continuous water, depending on what type of situation you're in. But what else?
It's slow.
It is slow, so how would that benefit you?
Doesn't lose a lot of water.
Okay, so you're using less water. You're wasting less water. You have a pipe that's near the ground, or you can even bury these shallow in the soil by the roots, and you would lose a lot less water. These are about 95% efficient, so you're only losing about 5% of your water. What's the drawback of the drip irrigation?
You have to run a hose through every.
Yeah, you got to run a hose everywhere. Okay, so that would be expensive. What else?
I think.
Where could you not use drip irrigation?
In places where it's dry.
Compacted soil.
Well, I mean, if you're going to run it under soil, you couldn't use it there, but I mean, you could just run it on top. What type of what type of crops could you not use drip irrigation with?
Corn.
Tall?
Crops that need a lot of water.
Corn.
Why not corn?
Because.
It's tall.
What in the world does tall have to do with it? Plants absorb water through their roots.
Because corn require a lot.
Any plant where you have a big field that you have to run a tractor through, could you have drip irrigation in it? No, because you'd run over it and bust pipes every which way but loose. If you ran a plow through a field with drip irrigation, you think you could do that? No. So this only really works where you have like what's in the picture there? Can y'all tell?
It's like, are they like grapes?
Yeah, so they've got grapevines. This is probably some type of vineyard they're starting. A lot of people do this in Florida and California with different like fruit trees, like we saw in the Biggest Little Farm video. They were laying down irrigation lines by all those fruit trees they had, and then they would just have like the openings in the drip line. They'd probably pop a little hole in the drip line next to the fruit tree. That way you're limiting how much water you're using there. And so anywhere you've got trees you're trying to start or grow in a dry climate and grow stuff, then you can use this. But you can't use this for like large scale, big fields. It just would not work. All right, flood irrigation. Flood and furrow here, A and B, are going to be very similar on page 247. So flood irrigation, about 20% of water is lost to evaporation and runoff. So the benefit of flood irrigation is what? There's no expensive equipment, right? You just turn the water hose on or the pipe on or open up a dam maybe you have above this, let the water in there, and it just floods the field. Or the same way on furrow irrigation. You open it up. This is not expensive farming, okay? So it's cheap, assuming you have a lot of what? Water, because it's also very wasteful. Flood irrigation, you lose 20% to evaporation and runoff. What else can you think might happen in that flooded field right there? Assuming you're not planting something that needs like a flooded field, like maybe rice or something.
Mosquito?
Well, there could be side effects of where you have like insects like mosquitoes. What would be negative toward the plants?
They're gonna get waterlogged.
Too much water, waterlogging. On the next page, it talks about this at the top. It talks about, let's see, where is that? It is more disruptive to plant growth than furrow irrigation, but slightly more efficient. I'm assuming it's slightly more efficient because it's actually coming in contact with the plant a little bit more than in furrow irrigation, but it is more damaging, could waterlog the plants, and could cause problems with their development. Remember, plant roots need what?
Nutrients.
Air.
They need nutrients, but they need air. And most plants, if their roots do not have air, they're going to die. So if too much water stays on them for too long and those plants aren't adapted for that, then they're going to die. Furrow irrigation. Furrow is less efficient than flood in terms of water loss. Your book says it loses about 1/3 of water is either lost through runoff or through evaporation. So furrow is just a fancy word for, we would say, ditch. Good. So you have little ditches or channels in between the bedded rows where vegetables are planted or whatever you're planting, and water flows down through there, and hopefully it soaks into the ground adjacent to them. If the water's flowing too fast, it could cause erosion, but definitely there's going to be a lot of runoff and evaporation from that type of irrigation. The benefit, it's cheap, assuming that you're not paying for water. And then the last one is spray or overhead irrigation. I want to correct a number on here. Obviously, this is the more expensive version of this, but the benefit is you get a more targeted amount of water in a certain location, and it is more efficient. If you look on 248, efficiency depends on when you're doing this, what time of day, and how much. If you live let's say, who's sitting back there? Smelly. Let's say you live next to a river and you're running a sod farm out in Foster's. If you're pumping water out of the river, you have a well that basically has an inexhaustible supply, then water's not a big deal, and you can spray water all day long, all through the air, and if 25% of it evaporates, then who cares? But if you live out west somewhere and it's super dry, you're probably only going to water when? At nighttime, late in the evening, nighttime, early in the morning. So you're going to do that in order to reduce the evaporation. And it says in your book here, drip and spray or overhead irrigation is 75 to 95% efficient. Meaning if you were really trying to do this and you did it probably at nighttime and you had those sprinklers facing down as they went around, you're probably going to be in that, you're only going to lose about 5 to 10% of your water. So it's much more efficient water-wise. It's much more controlled where you're putting the water than in the furrow or the flood irrigation, and it doesn't require as much water. To flood a whole field requires a lot of water. Okay, so for those of y'all who don't know what this overhead looks like, have you ever been out toward Foster's on the interstate? You see those big overhead units they have? Maybe you've been out west somewhere, Midwest, you see the big overhead units. Maybe not. Turn to page 289. If you ever fly in a plane and you see some gigantic round circles like this that are usually greener than the area around them, that's probably been made by what? Trent?
People.
Aliens! I'm just kidding. Okay, yes, people farming. So why is it in a big circle?
Because the thing moves and stuff.
Yeah, so you have a pivot point in the middle. You have water coming up through a pipe or a well. And then you have this big overhead sprinkler with wheels on it, and it just pivots around in a big circle. Okay, and if you flip over to 290, Jeremiah, maybe you've seen one of those overhead sprinklers like they have at the top of the page there. Like I say, they have these out. They use on sod farms and some maybe some corn and soybean places out toward Foster's. But you see these all throughout the Midwest where they don't get as much rain as we do, and they grow lots of crops. Okay. So can be much more efficient and much more controlled in terms of water usage. But one of those big units right there, I would venture to say you're probably talking in the hundreds of thousands of dollars for one of those to buy it and get it up and running. So it is expensive, but if you're growing lots of plants, then maybe it's worth it. Yeah.
Speaking of flood irrigation, how are cranberries grown with the flood irrigation?
Cranberries usually grow in waterlogged areas. I don't know how the plants actually grow.
No, they just flood it to pick them.
They flood it just to pick them?
Yeah, because they float. So they just flood the fields and
And then they get it collected off the top? I didn't realize they weren't flooded before.
Oh, I've seen that commercial.
It's still in low-lying areas though, right?
I think so, but I know they just flood it just to pick them.
Oh, Interesting. All right. So, any questions about irrigation? Yummy. 290 at the top. Waterlogging. Waterlogging means what?
Clogging it with water.
Too much water. You've raised the water table, how much water is in the soil there, and it's flooding the plant roots and causing them to die. They're not getting enough oxygen. They can rot. I mean, there's a number of different problems when you have too much water in the soil. If you have an area in your yard that you have difficulty getting anything to grow, it could be because it's kind of a low spot. Maybe it's got a lot of clay, holds a lot of water, and causes issues. Hey, if we have time, if y'all remind me, we'll go out to the tennis courts. Jeremiah, are they supposed to put those pipes in today? We'll go out there and look at the soil because it's kind of interesting. They dug some very large holes to put power poles in out there. And the soil that came out is different from one end to the other. Did you notice that, Jeremiah? Who else plays tennis in here? I don't know about you, but definitely him. Yeah, so, Smelly, you play tennis?
No.
Oh, I thought your hand was up. So, and I'd like to go out there and look at that and talk about like why, and this one over here is like really wet, and that the two piles over on this end, and over here it's very, very dry. There's a big contrast between the soil and the moisture content. So if we have time, we'll go out and look at that at our break. What were we doing? Oh, salinization. Salinization refers to salt. Let's turn to 237 real quick. I'm going to come back to that since that's our lab, and then we'll do that one last. All you people at home, I know that's what you've been waiting for me to talk about our lab today, but these other 16 minutes have been a beautiful conversation between me and you. 237, what is an aquifer, Ashley? Ashley's aquifer, that's got a good ring to it. It's better than Ogallala, am I correct? Never mind, what's an aquifer?
It's a source of usable groundwater.
Yeah, it's water underground, like a big area of water underground. Good, that you can use for stuff. Turn over to 238. In the Midwest, there's a very large aquifer called the Ogallala. Good, you need to write that down. You're going to see it on the test. I can almost guarantee it. Okay. This very large aquifer that extends through the Midwest is very important to that region because what's going on in that region? Lots of crops and cattle. Why is the aquifer so important to them? Besides the crops and cattle. Yeah, it's really dry. I mean, you're getting into, remember how we talked about you have grasslands and you have deserts? So this is getting into like dry grass prairie, and then you've got deserts close by. So this is a very dry area. They're very dependent upon groundwater. Now, the problem here, if you look at the top of 238, confined aquifers, meaning ones that are like kind of trapped below ground and down in below the rock, on the other hand, are generally recharged very slowly, perhaps over 10 to 20,000 years. Meaning, if you suck too much water out of these very large, deep aquifers, it's not going to ever refill or recharge anywhere close to our lifetime. So you have lots of people throughout the Midwest who are pulling water. And just imagine it's like a gigantic milkshake. And people are all sucking out of the same straw here. And eventually, if you pull too much out of that, there's going to be nothing left. And there are a lot of people who depend upon agriculture in that region. So I don't know what they do if that water source runs out. Okay. On 239 here at the top, if you and your neighbors are farming, what do you want? If you live in a dry area.
Water.
Yes, you want water. So you have to have a well. What kind of well do you want compared to your neighbors?
A better one, deeper one.
The deeper one. It's just like if you have a giant milkshake. And some of you draw short straws that are only like this long. And then some of you get a straw that's like goes to the bottom. Who do you want to be? You want to be the long milkshake person. The part where if you get the chocolate chip cookie dough milkshake from Dairy Queen, that you can get down there and get those chocolate chips and cookie dough. Right, Quinte?
How good is Dairy Queen?
What?
How good is Dairy Queen?
Let's not get off track here, Donovan. Okay, so the problem is if you've got one person with a deeper well than the other, what can that cause?
Cone of depression.
Well, cone of depression, but what does that mean?
It means that other people can't get water.
Yeah, you're lowering the water table as you pull water out if you're pulling too much out. One thing I want you to add in on 239 at the bottom, saltwater intrusion. People that live close to the ocean have to be careful how deep they dig a well, because they can get into, you've got fresh water that's moving through the ground going out toward the ocean. That's just kind of the natural movement. But if you pull too much of that fresh water out, The salt water is also coming in from the ocean, and it can do what? It can intrude and get into your well, and if you get salt water in your well, what happens?
Can't drink it.
Yeah, I mean, like, everything dies. Don't drink the salt water. It's bad for you. And don't put it on your crops. So, salinization from irrigation can... What happens when plants get exposed to salt water?
It dies.
Yeah, so Lake Tuscaloosa, Black Warrior River, underground water. Is there salt in any of those? Salts? Yes, a little bit. Especially, I think, probably more when you're talking about groundwater, because you're probably going to have more salts and minerals and stuff dissolved in that groundwater. So it's a very small amount. Let's say that's your only source of water. You're taking water out of there. You're not getting much rainwater. You throw that on your field. Part of that water evaporates. You irrigate some more. You put that water on your field. Part of that water evaporates. Your plants grow. What's going to happen over time to the soil in your field? That little bit of salt is going to do what? It's going to build up. Now, this may be over the course of decades, but a lot of places that farm, they've been farming for decades. And over the course of time, the salt can build up, build up, build up, build up, and then that can cause what? I mean, yeah, it can inhibit plant growth. It can cause them to die. Salt can kill plants at certain levels. So that can be an issue. Now, the lab you're going to do is salinization lab. So you can put up your book. At the top of it, you can do this on the back of the biggest little farm. At the top of it, you're going to put salinization lab. Apes. Number one, you're...
What are we doing this on?
Exactly. Did you do the web quest?
Not yet.
Okay, well then you're going to have to watch the biggest little farm with us.
Okay.
How does salinity affect plant growth and development? That is your question in the scientific method. So you're coming up with your own experiment. Sorta. I'm going to give you some parameters. You got to come up with a hypothesis with your group members.
You want us to do this on the back of our farm video? Answers? Is that what you said?
Jordan, can you yell at her for me? Thank you.
I was just reiterating.
Experiment. So you're going to have to write down how you're going to conduct this. Your variables, independent, dependent, control. Why does my finger look so big there? Data table and conclusion and LD50. I'll explain what LD50 is later. This is going to run for a week or two. I don't know how long. It's just going to be long enough for at least the plants to come up and germinate and for us to see a difference between, hopefully see a difference between the different groups, the experimental and the control groups, or control group. So, you guys over here on this table, or a rolly cart, I've got 6 different solutions and just tap water in the middle. So these are the percent salt solutions that I have over here. Hold on a second. So I've got 0.5, I've got 1, 1.5, 2, 2.5, and 3. And I've said I want y'all to do a control plus 3. So do your control, which would be what? Okay, just your tap water. And then you need to pick 3 of the others. Okay? So I don't care which 3 you pick. Maybe you pick 3 at the bottom because it's more salt. Maybe you pick 3 at the top because maybe that's more likely to affect it. Maybe you pick every other one. I don't care. It's up to you. You need to have some rhyme or reason though. And then there's pipettes in each one of the containers over there. So once you've got your Petri dish ready, you've got your seeds in there, you need to put a paper towel in there and then put your seeds. The paper towel is going to hold the moisture for that. Okay? You can put it on top or on bottom. I'm going to leave that up to you how you do it. It might actually work better. I don't know. I'll let y'all figure that out. I don't know that much anyway. That's why I'm working this job. Okay, so anyway, whichever ones you want to do, make sure you whatever beaker you get the pipette out of, you put it back in there. So you're going to come up and add your stuff to it. So don't take the beakers off and the pipettes off, okay? And that'll be kind of the last thing you do in your setup. So you guys are going to have to cut out I've got Petri dishes. I got a bunch up here. I've got some over there by, can you grab one, Colby? One of the ones that's got like a 4 split in it. I've got Petri dishes like that are already split up into 4 sections, so it would only require 1 Petri dish per group. Or if you can't get one of those, or you want to use a bigger one, you can use just the 4 different big Petri dishes. It's totally up to you. You're going to cut out a paper towel to fit down in whatever you have, and then you're going to add your water to it. So, in whatever % salt solution. Now, to give you kind of a frame of reference, tap water, I mean, the amount of salt in it is probably less than 0.1% if I had to guess. But in the ocean, what's the % salt water? What?
Is it like 3.5?
Yeah, it's roughly like 3.5. Yeah, somewhere around there. So, and then we know like ocean water would kill any of our plants that we normally do. Okay, so, and then the other thing you're gonna have to figure out is what type of plants you want. So I've got radishes, beets, peas, in this little jar right here, all these brown seeds. This came out of like a game plot mix that I have. All the brown ones are either rye, oats, or wheat. I would just get the same type of seed because there's some different ones in here. And I would use at least get 3 seeds for each group. That way, if you get a bad seed or 2, then like at least one of them will come up. Okay. So, but just get the same type of seeds if you get them out of here. Okay. Or you can get seeds out of one of these. I don't care. It doesn't matter to me. Okay. Maybe it affects different plants in different ways. I'm sure it probably does. So maybe that's something that we'll look at when we get our data sorted out. So you're going to get your Petri dish, get them set up, figure out what you're going to add, get your seeds, add your salt solutions. When you're through, don't use a Sharpie, use one of these like dry erase markers and write your initials on them and what treatment is on each Petri dish so that you'll know, and just put them up against the countertop out of the way somewhere. Okay? So each day you'll come in over the next week or 2 and we'll check those until we get some data to see how they're germinating and growing. Any questions? Y'all guys got about 20 minutes to get this set up and sorted out and your experiment written out. And then, like I say, then we'll go outside after that, okay? Go. Oh, you guys need...